Good evening, everybody. Just a few faces I don't recognise here, so just for those of you that don't know who I am, my name is Andrew at M1CJE. I've been playing with electronics since I was about that big. I think I started taking things to bits as soon as I could hold a screwdriver. I'm sure many of you did. I didn't start putting them back together again until I was about 10 or 11 years old, but eventually I learned a few things. I've got no formal training in electronics, so those of you who are electronics engineers, feel free to put me right if I say something wrong. I'm totally self-taught. The only reason I'm a radio amateur because the only training I could actually find was the radio amateurs course. I went on that to learn a bit more about electronics, learn some of the things that I didn't know. That's the total extent of my electronics training, so bear with me if I say something that you don't agree with, tell me. Tonight I'm going to have a look at some of the steps involved in a home construction project. Seems falling a bit. I'm not going to cover the whole thing. I'm basically going to look at the steps involved in taking a prototype. I'm assuming you've got to the point where you have a working prototype of a project and you want to turn that into something that's a little bit more durable, that's going to be a product you can actually use in your shack. So we're not looking at commercial stuff here, it's totally aimed at the home constructor. So hopefully if this works, it all starts with an idea. So hopefully you've got something you want to make, some kind of gadget or an amplifier or a radio, whatever it is you want to make. You want to make a circuit of some sort. So for the purposes of tonight's talk, I'm not going to use anything too complicated. I'm just going to look at, as an example, a simple power supply project, so regulated voltage supply. So from the idea, the next thing you need, it's not that button, you need the button, you need that button. You need a circuit diagram of some sort. You're going to come up with a design. I'm not going to go and cover any of the work up to this point. I'm assuming you've already done all this, you know how to do this. What we're talking about is from your design through to a finished usable product. So there's a very simple design roughed out. Anybody spot the deliberate mistake on there? There is a mistake on there, if you can't spot it. That's a very simple variable voltage regulator. Put 0 to 30 volts in, you'll get probably from about 2 volts up to about 25 volts out, according to what you want. There's a little potentiometer at the bottom there you can use to adjust your output voltage. So it's a very simple circuit, not really too worried about the details of the circuit. There's ways you can improve it. It's more just as an example we can work through. So, anybody here ever actually done one of those? Yeah, I'm sure plenty of you have done. Years ago. Right. So where do we go from here? You need to prototype that, which is where the talk starts. So there I've got a little example prototype. That's that circuit, which I'll pass around so you can have a look at. I've tested it, it does actually work. So, as promised, Roy, there you go, you can have a look first. That's built on a breadboard. That's what I mean by a prototype. You might have done it like that, you might have done it Berkeley style. There's various ways of prototyping something, but that proves the concept, proves the circuit works, but it's in no way suitable as it's not going to last the course if you try and actually use it as part of some other project. So this purely built for prototyping purposes. Make sure I've got the right value components, got them all in the right places. Where do we go from there with that? We need something a little bit more durable. So the options you've got now, you could build something on strip board, something like that, which is the same circuit again, built on a bit of strip board. Thank you. There you go, see if you can spot any differences. That's a bit more durable. That could be a finished product depending on what your use case is, but if you, it's not an ideal solution, but it'll work. Really, the best solution is to build a PCB, which is the title of the talk. So another option is etch your own PCB. So that's a totally different circuit. It's one I dug out of my scrap box. Been depopulated, but that's a PCB that I etched many years ago, before I discovered the solution I'm going to show you tonight. So etching your own PCB it's a nice solution. It does work. A bit restricted. It's difficult to do double-sided. It's you don't tend to have silk screen printing on there, things like that. But it'll make a nice working project for you if you want to. But it's difficult to replicate. Difficult to get it right once, let alone more than once. So I think generally when I was producing my own PCBs through etching, you usually have 3, 4, 5 attempts before you actually got one that worked to satisfaction. So not a great solution. Fortunately, the Chinese have come to our rescue. There are a number of companies around now that will take your design and produce a PCB for you. So, digging through my magic box of tricks here again, hopefully I should have. But that is our circuit up there again, produced by a Chinese manufacturer. There's a screen.
Yeah.
Not populated yet.
Wow. Something else.
Actually, I've got a populated one here thinking about it.
That's quite
So that's the same thing again, populated. It's not exactly the same as that circuit because I think I've enhanced it. I've put a fuse into it, things like that. It seems to be like a good idea to put a fuse in just here. So that final design has got a fuse in it. And there might be 1 or 2 other bits and bobs in there, I can't remember. But so how do we get to that from our prototype? You're going to need a CAD package of some sort. You're going to be able to draw your design up. So you need to draw, probably start by drawing that circuit into a design package of some sort, and then convert that to a PCB. There are a number of tools around. I do believe we had a talk a couple of years ago on one of them. Which was the one you talked on?
Eagle and Fusion.
Eagle and Fusion. There's others around. What we got? Altium. About £7,000 for a license for that, if you fancy using that. Proteus, I don't know how much that costs. Probably so much I don't even tell you. KeyCAD, that's a free one. So there's a few of these tools around which you can use. And I haven't played with Altium, but I've played with a few of them to see how. And the problem I have is I found they're all just too complicated. If you work all day, every day on these things, they're great. There's probably very little they can't do, but you need to be using them all the time. They're just so complicated to use. So I've tried quite a few different ones over the years and never really got on very well with any of them. This, I think the Chinese must have realised this was a problem as well, because they wanted to address the hobbyist market and they needed a tool to do it. So one of the manufacturers, Chinese manufacturer called JLC PCB, came up with a tool which you may or may not have heard of, called Easy EDA. Anybody come across Easy EDA yet?
Yep.
Yeah, 1 or 2 you have. So Easy EDA, I had a look at that. As soon as I looked at it, I recognised things on it. I could see things that we were doing. Let's just have a look at that. That's the website for them, and hopefully, if the internet's still working, we can pull it up. Not that one. That one. Right, so that's the website. This is live through the internet, so you have to do anything that doesn't work very well. If you go to that website that I just said, that's where you'll end up. That's the landing page. Now, I'm going to have to go and sit down because I need to drive the PC, so if you're struggling to hear me, let me know, and I'll try and reposition myself a bit. I'm going to have to sit here and press buttons. Right, so big white button up there. So you can go to this. I've got cookies coming up there. Let's get rid of those. You can go to this from any web browser. So the nice thing with Easy EDA, number one for me, there's nothing to install. It's totally web-based. So you don't need anything. You can use any PC that's got a web browser on it. Presumably you could do it from your phone if you want to. I'm not sure I'd want to design a PCB on my phone, but it could be done, I'm sure. So web-based, no installations. Press that button there, and see how fast the internet is. It brings you up to this page.
Now what I liked about that, straight away, I recognise some of those things. I know what that is, I know what that is. Now none of the other packages that I pulled up came straight into a page like that, so I can see things that I recognise. Also over here, I understand what that means. So, learning curve, just above 0. And that really appealed to me. So I persevered with it and started pressing a few buttons. Now, I won't click that immediately, although that's the obvious thing that you would probably expect to click. Get rid of that conduit off the side there, that would probably help. I'm going to be using that side in a minute. Although that's probably the obvious thing to click, and that would work quite well. If you want to actually create projects, it needs to know a bit about you. It expects you to be able to log in and have an account. You don't need to do that to use this tool. You don't even need to set an account up. You could just use it as it is. And if we go up to File, which any Windows user is going to recognise, File, New, Schematic. And I've got a drawing page. I can start drawing. It didn't take very long to figure out if I want a resistor. I'll put that over there. I click over. If I do, there's two options. You either click and then click there to place it. The other way you would expect to do things is click and drag. And if you do try dragging like that, you get a nice little helpful message that says, oh no, can't do that. Click and place it. So there's my resistor. Wheel on the mouse, zoom in so I can see it to read it. So I can zoom in and out like that, very quick and easy. So marks out of 10 for ease of use so far. I've given it 10 out of 10. Unfortunately, you can't see my drawing. I've got a copy here just in case I can't remember it. So I remember there was a resistor on there. I need a variable resistor. So click, I've got a variable resistor. There's a couple of capacitors there. Click on there. Let's have we have an input capacitor, we have an output capacitor. And I needed electrolytic, so just down the page there you'll see there's an electrolytic. Let's have one of those. What else did we have? We had a diode, didn't we? So somewhere down here we should find a diode. There's a diode. Pop him up there somewhere. Oops, I put 2 in there. I think I did, yeah. Get rid of one of those. Delete button. And the other thing we needed was an LM317. Now I think there are some regulators down here, but 337, there's a 317 there, but it's a dual output one, it's not what I want. So obviously not everything you want is going to be on this list here, that's the bottom of the list there. So that, most of the basic stuff is there, the glue components, but once you get into chips, you need to go and look for that. So here we've got a library, seems like a reasonable place to look, doesn't it? So we'll go in there. Up here, keywords, at least 3 characters. So if I type in there, LM317, that's not 7, that's a 2, 7. Right, yeah. That's the sort of generic term for a variable voltage regulator. That's the search button. And there'll be I get hundreds of different 317s. These are all different manufacturers' part numbers here. So we can pick, we need to pick the right one. Now I know I want a TO220 package, which is the sort of the ones that you see on those boards that are going around. And up here, look, I can see the footprint. So an SO223 is a surface mount device. A TO252 is also surface mount. Then the next 2 down are TO220s. They're both nice through-hole components, nice and easy to use. So if we just click on one of those, you'll see over on the right-hand side here, we get the circuit diagram signal, we get the footprint that's going to be on the PCB, we get a nice little picture of it as well, so you can just be sure that's what you want. That should look remarkably like the ones that are on my board. There's a couple of them there, 2 different manufacturers' part numbers. If you're particularly worried about it, Google those part numbers, you'll find the data sheets for them to decide. There might be some minor differences between them. For our purposes, it doesn't really matter which one we use. All we're really interested in is the correct footprint, so that I'll use the ones out of my scrap box that's lying around, and we'll do something special. So we'll pick one of those, let's pick that one for a change. And down here there's a button that says place, so press that button, and look, there's my regulator. The second one. Right, so there's all our components. I think that's everything we needed. We now need to join it all together. So start with the diode, that's facing the wrong way. So if you know the circuit of a 317, that's just a protection diode that goes across from pins 2 to pins 3. It goes across here so that when you turn it off, this big capacitor down here, the big electrolytic doesn't reverse, go backwards through the regulator and blow the regulator up. So that's all that's there for. It's facing the wrong way though. So on the keyboard I press R and it turns round. It's not enough, another R and it goes round there. It's as easy as that. Drag it across to where I want it. I'm going to put it between pins 2 and pins 3. So I need to connect them. Up here we got some wiring tools. Hopefully it says wiring tools. And that one there is a bit of wire. So I'll get a cursor like that. If I go to, let's zoom in a bit to make it easier to see. If I go there, see the black dots just appeared. That's now on the connection point. So I'll click there. I'll come across over here, bring it down here. I want to just anchor that point, so I'll click there and back dot there. So that's connected that together. And I'll do, so I've got rid of the wiring tool. I'll do the same again on the other side, down there. Oh, wrong button, never mind. Click another wire in there, and it'll automatically join them all together for me. And that's that wired in, as easy as that. Now, the resistor down here, that goes between pins 1 and 2. Actually, let's get that here out. The variable resistor, I want to turn that around a bit. Press a couple of R's, or a single R. Now I'm going to connect that to pin 1. I don't have to use the wiring tool, there's an easy way. I just touch it onto pin 1 like that, and when I drag it away, it'll automatically be wired up. Like that. I want to connect that resistor into that notice there. Dunk. You see the red blob confirms that it's connected. I want to get the other end of that resistor up to just there, dunk, like that. The bottom of this VR is ground, so there's a ground tool up here somewhere. There you go, ground. Let's pop a ground on the bottom there. Yeah, put it on there, and then I can back there. And then the slider needs to be connected to ground as well. Now I can't drag that around and touch them together, so I'll have to use the wiring tool for that. Bring that around, and join that to ground there. You see how quickly I'm getting my circuit together now? I know it's not a complicated circuit, but it doesn't take very, very long. Let's pop the decoupling capacitor in over here. Turn him round so he's the right way around, and we'll be wiring to. If we connect, in fact what we'll do is we'll connect from there across to there. Should turn that one around as well first of all. Now this is the electrolytic polarised component, so you need to get that the right way up. These 3 reversals, get the positive on the top. Otherwise we'll have a little bang. Right there, and we can wire that in. There. And then our output is going to go across here to there and there. I missed that one. Yeah, I did. Oops. No, not a problem. Get rid of that. Too many clicks. Just delete that out of the way. And I might as well delete that one out of the way and do that again. Sorry about that. Right. One more component to go. Over here we've got the other decoupling capacitor for the input side. Rotate that around there. So pop him in. He's going to go about just there somewhere. Connect it from there to there, and then from there to there.
Andrew, if the internet were to go off now, where would that leave your circuit? Is it automatically storing it, or do you have to manually save it for want of further discussion?
At the moment, we're not logged in. And unless you log in, it won't allow you to save anything.
Okay.
So we'll see that in a minute, because I'm going to log in a minute, because we're a bit restricted. I just really want to show that you don't even need to create an account. In a minute, I'll log us in, and I'll be able to save this and do various other more advanced things with it. Right, so there's our circuit. I just want to make a couple of changes. I don't like the numbering scheme on the VR. I don't know what RP stands for, but I tend to call them VRs, so I'll just double click that. I'm going to call that VR1, short for variable resistor. And I presume that's the part number, but I'd rather that said something like ADJ, short for adjust. So I'll change those. My values are not quite right. That should be 100U, so again I'll just click that and put a couple of zeros in there. That's 100. Those were correct. They were, I think that's 0.1U. No, it's 1, right. That should be a 0.1. They're 100 nanofarads. Click that one there, change that to 0.1U. And that one there should be a 0.1U as well. For what we're doing here, if we were going to create a bill of materials and get this manufactured for us, we would need to be absolutely sure we got the right part numbers. But if we're just going to produce a PCB, the really important thing to us is just that we've got the right footprint that fits our components. So this, for the purposes of what we're doing, because we're not going to get it built for us, this is just text really. If I was going to get it built, I'd have to look up the correct part numbers and use those instead. Right, everything else other than that should be a 4002, I think. So a few tidying up bits here and there. That's simple enough to do. That everything you just click on it. 1K, that was meant to be a 240, I think. Was it 240 or 220? Can't remember now. 240. Right, I think that's everything. Now, at this point, I mean, that's good enough for what we need. There are lots of other things you can do here if you just want to play around with it. Select these 3 capacitors. I think they look a bit untidy, scattered over like that. So select all 3 of them. Up here is an alignment tool. So all the stuff you'd expect in any drawing package. That's a line down there, I think. Well, I've disconnected them all, unfortunately. I shouldn't have done that. I'll have to redraw the wires, but rather than doing that, I'll leave them messy. So there's usual Windows keys. Control Z is undo, puts it back again. So I don't. I'm not going to align them for this. Right.
Do you need an input and output?
Oh, good point. Yeah, I need an input and output. Forgot about that. Let's put some plugs on there then. So down here we'll find some plugs. Yeah, there's some plugs. There's a header male, header female. If you notice by the side of it, there's a little drop down there. So we can drop down. We can choose whatever header we want. So if we wanted a 5-way, a 5-way. But we do actually want a 2-way. So 1x2 there. I want male or female. I want male headers, don't want male headers there. So let's have a couple of those. Pop one on there and we'll pop one on for the output. So 16 bits, I've got room. I think if I work on it. But that's, don't want all that horrible text there. Let's just change that to the in. A bit more meaningful, isn't it? No prizes for guessing what this one's going to be called. The out. So you notice you've got pin 1 and pin 2 on them. I like my pin 1s to be ground, so I'm going to turn those round. So this is facing the wrong way, so I'm going to rotate it. Put it over there. So now that's fine. That's what the way I want it. Pin 1 ground at the bottom, pin 2 up there. Well, this one, when I rotate it, it's facing the wrong way. So now I've got to flip it as well. So to flip, it's that one there, isn't it? There, yeah. So yeah, pin 2 at the top. That's going to be my output. Line it up there. Put a wiring tool in there. Oh, I missed. Oh dear. Well, my mouse skills are not as good as they could be. Try and zoom in a bit, then I can get it right. And then pin 1's got to go down to ground. And the same on the input. Wiring tool, pin 2, just to there, and pin 1 down to ground. There we go. So we've got an input and output. No fuse on there at the moment, and you'll see when you see the final one, you'll see there's a fuse on the output as well. It's not a bad idea to stick a fuse in here or something maybe. Let's move that over a bit so it's not. Oh, disconnected those. All right. I'm not going to mess around with that, I'll just put it back where it was. But yeah, I would normally tidy that up a bit and make it all a bit more presentable. But that's fine like that, that'll do. Now at that point, that's our diagram. I think we can print it at this point, but we can't save it. So, there was a Den's question there. We can't actually save this at the moment because we're not logged in. We need an account to be able to do things like saving. If you look when we did the file, we could now go ahead and do new and do the PCB layout if we want to, but we can't link the two together because you can't convert the schematic to a PCB unless you save it first, and you can't save it unless you log in. So at this point, I'm going to log in. If I try and create the PCB automatically, which it will do for me, and normally I would, is that convert schematic to PCB? If you look down the bottom right hand corner, you'll see an error message come up. Please save your file before convert to PCB. So not unreasonable, you've got to save it first. If you go into file and try and save it, you'll find you can't because you're not logged in. So if we click on that, it's going to, which one is it? Probably save actually. It'll take us to the login screen. So there we go. That screen pops up. Register now if you haven't got an account. It's a few years since I did it, but I'm fairly sure there was nothing onerous about it. It was just your name and email address, that was pretty much it. But I'm already registered, so my email, I've got to make sure I'm not a robot. I don't know a robot. Remember me? Yeah, I can remember me, it's my PC. So log in there, and that will log me in now. And suddenly, you'll see all my projects come up on the left hand side. But more importantly, I can now save this project. So you see it's a star new project, although star means it hasn't been saved yet. So if we go into file and we save it now, I'm now able to actually do it. So let's give it a title. We'll call it, we better not call it SDR demo because I think I've already done that. Yeah, it's down the bottom there. So what should we call this? Thursday talk.
You have been busy, Andrew.
Well, I've been using this for years. So some of the early ones, the ones that before I discovered that they only charged $2 to print them, I used this tool to draw my PCB and then etch it myself. So some of that one that's going around that I etched myself is actually in here somewhere. If I dig through, I can figure out what it. I've got a feeling that's a phase lock loop circuit. That one. Anyway, save that. We can put some description and stuff like here if you want to, but that's out for the moment. Right, that's now been saved. What's that message say? You can do something. You can now create files under this project. Oh, great. Right. It's now changed its title to Thursday Talk, and the star's gone, so it has now been saved. We should find in our projects list here. Somewhere in alphabetical order. No, it's not. Where did we put it? It'll be in here somewhere. There it is, Thursday Talk. Sheet 1, we can change that title, so if I look at some of the other ones, most of mine, see they've got names in them. So I can't remember how you do it. Do you just press on that? Yeah, probably press on that and modify, you can change the name of it there. But it's actually got the project name up here. So what we want now is a PCB. The whole point of coming in here in the first place, wasn't it? So if we go to design, convert schematic to PCB. Press that button. Let's see if I've forgotten anything before I press it. No, I don't think I have. Right, we'll press that, let's see what happens. And this is just some basic stuff about the PCB. It will have automatically decided how big a PCB you need. So if you aren't fussed about the PCB size, then you just click apply. If you're trying to fit it into a specific case, you might want to change these heights here. You don't have to though, you can change it in a minute if you don't. Units, millimetres, take note of that because I couldn't remember what they were earlier on when I was practicing this afternoon. I couldn't remember if it was inches or millimetres. Makes a big difference if you get them wrong. Like 2.5 times the size you want. So I've accepted that. So there's our PCB outline. Now this is a drawing tool again, like the schematic was. So I can select this and I can go around with it to my heart's content. I can either drag things around, or I can set things by numbers here. If you've measured your case that you're trying to fit it into, you can put the precise dimensions in here. But this will be big enough to fit that lot onto. It always provides you with an example one that's big enough. Yeah, one important thing that I discovered fairly early on is, and I always forget, is if you are going to put it into a case, before you position all your components, put your drilling holes in first of all, your matching holes. Because the number of times I've placed everything and then suddenly realised, oh, there's not enough room there to get the holes in.
And connectors.
Put
your
yeah,
connectors
so
on
we've
as
got
well.
the connectors in here. Those are included. They're just down there. So
No, what I mean is you position them first.
position
where
them first.
they need
Yeah,
to
it's a good
go.
idea to get those in first. If anything that's haven't been in a fixed position, put those in first. I moved all this earlier on. That's why it's all on top of each other. So up here, we've got some fairly handy looking tools. Doesn't take too much to work out. That's a hole. So it says hole there. Excuse my mouse pointer. I've got bad eyesight. I have my mouse pointer massive. It's not just for your demo. I always have it that big. It always covers up all the text tips. So you can whack your holes in. Let's put four in the corners. One there. And there. If you can just get used to doing this first, because it's a nightmare trying to think. The number of PCBs I got with holes or in all sorts of odd places. Right, there's my holes in. If you want to mess around with them, select them and you can change. If I select it, yeah, so there's your hole diameter, there's the centre X coordinates, centre Y coordinates. So you can mess around with that all you want. Oh, it's a good idea as well to lock them, because otherwise you end up moving them accidentally and you suddenly find anything that's fixed like that, that's going to fit the case, I tend to lock it if it's something I don't want to, you know, it's got to be in the right place all the time. So I would generally tend to lock the board outline and lock all the holes so that they can't move. So that's just a case of select them, turn that on. I won't for a moment just in case we need it. And the other thing I usually forget to do, if you look at the yellow is the silk screen here, this little thing up here gives you an idea of what everything is. So those are traces up there, red's on the top, blue's on the bottom, the yellow is the top silk layer. So you can see at the moment all we've got is the part numbers on there, so I don't know why it defaults like that, it always does. If you select everything at this point, it's very easy to select them all. And up here, display the name, turn that to yes. So suddenly you've got all the names up here. It shows a lot of mess around later on. So now all we've got to do is we've got to move all those bits onto the board, because at the moment they're off the board, so the auto router will have a bit of a job routing those. So let's pick them all up and try and fit them in. So let's put that somewhere near the top there. As James says, your connectors, it's a good idea to get them on fairly early on. Put them on there. Same as the other tool, R to rotate, so I want that over there. And we'll put it up in that corner there. You notice me silk screen's off the edge, so I'll have to deal with that in a moment. The output connector we'll put over there. Down a bit and zoom in a bit. Rotate that one round. Yeah, that way, no, that way. Oops. Yeah, that way go. You need to have just, the auto router will route most things, but you do need to think a little bit about some things. Don't make things that are impossible to route without going to a sort of 6-layer board or something like that. I mean, you can always route things, but you might just have to keep adding layers. By default, you will get a 2-layer board, so both sides of the board, and most things can be routed automatically on a 2-layer board. But it's possible to route things that are not resolvable. The auto router is not magic. Let's put our potentiometer there. We'll put our capacitor up here somewhere. There's a bit of room. Right, these are our decoupling capacitors. It looks like the wrong footprint there. They should have been a lot smaller than that, so I probably picked the wrong device there. Let's rotate that one around. So that can go 2 ways, so make life easy for the router. Get them all the same way. I'm going to be able to fit all this in actually. So I put those holes in. Let's get the other capacitor up there. Rotate it in around. If you spend a bit more time on this, you will get a much nicer result. The diode, let's move all this up where I can reach it. Put the diodes in going, it's going to go across there somewhere, so it'll be around like there. And that's going to have to go in there. But it's a bit messy. You can do a few things. Right, some of these texts that are hanging off the edge, you're going to have to do something like that because it won't be able to work with those. So that text there, if I just click on that one piece of text, I can move that over there, just move that way a bit. Get that one on board. V in, we'll put that just here, and let's rotate that to there, and put it underneath, and the J1, that's fine there. Let's rotate the V out, so that's the right way up as well, we'll put that there. There you go, so it's as easy as that. I mean, obviously you could spend ages playing around with this now and make it look prettier and prettier. But what we're interested in, if you notice these little blue lines everywhere, these are the connecting lines, so those are all the ones we've got to wire up. And we have got a wiring tool up here, we could sit here. And before, the auto router never used to work very well. I used to do all this by hand. So you sit there and you make a track like that. So that one's now tracked in. You need to track every single one of those blue ones in. But the auto router has come on in leaps and bounds now. So we'll have a go with that and see what that can do. So that's up in route, funny enough, under auto route, and then auto route. Now, this will bring up this screen here. The only thing you need to worry about there is your design rules here. So this is where you're going to set things like track width. Now this is a power product, so a 1/4 mil width is not really big enough. So I want the tracks to be 1 mil wide, really. Clearance between tracks is 0.15 mil, so that's a bit tight. We've got loads of space, so I don't think that affected anything. No. How much clearance do we have? 1/2 mil? So 0.5. I hopefully haven't got any veers. If I do, then that's the diameters and the drill, the hole through the centre of the veer, so you can set those here very easily. But that's good enough, that'll work for us at the moment. So, spin that, and this is where we find out how good the internet is. Earlier on I had a lot of problems with the router, because this is running the router on their server. It's a cloud router. It's taking a little while, looks like it still is taking a little while. When this works, it tends to route that board in about 30 seconds or less. But
I think your diode thing is
oh, I still missed the diode off, have we?
D1 is going underneath the
Yeah. What's the matter with that?
D1
The screen, the
D1 4002.
description is.
Oh, it doesn't like that, does it?
Yeah.
Okay, let's cancel the router and see if it'll stop. Move that. Yeah. You can run the router locally if you, I'll get on that in a minute, but at the moment I'm running the router on their server, so right now might be a problem. So it does, sometimes it just runs immediately straight through, and sometimes it takes a while. And there you go, like that, see, that's how it does quite often. So it's attempted 20 connections, it's completed them, so great, we've got a 100% pass rate, so that's actually routed it successfully. It won't necessarily be pretty, but it's it'll work. Personally, I probably wouldn't have done that if I'd done it manually, but it would have taken me a darn sight longer than that. One thing I normally do at this point is, most of my circuit boards, when I show you some examples, I always copper fill the back panel with a ground plane. Even if it's just a power board like this, I'll still do it because it doesn't cost any extra. So I'll put that in here now, and that'll give us all the grounds will just go straight through to the back plane there. So I think it's that one there is the copper area. So it's going to be the net on it's going to be on it's called ground, which is fine. And to do this, I can actually put this outside the board nice and easily. I just draw the area that I want to copper fill. And it's quite happy to be outside the board. It won't try and fill the whole universe. It will just fill the bits within the board. I think, did we join that up? Yeah, I did. And there it goes. Right, that's put a copper area. Unfortunately, it's put it on the top. I wasn't paying attention, but that's not a problem. You just select it, change the layer from the top to the bottom, and that's now put copper fill on the bottom of the board. If we move something, like say we move this capacitor, of course that's going to be a bit of a problem. We've now got a short between our positive and the ground on the other side. So at that point, every time you move something, once you put the fill in, you just need to rebuild your copper area like that, and it will recalculate it for us. Right, that's basically our board. We'll just save that. So you go file save, there's a quick shortcut which you get used to using, Control S as with most editors, and that saves it for us. Now what we can do now is go into view, we can have a quick look at this board, 3D view, And because it knows what we've got on there, it was quicker than me at building, wasn't it? And there's your board. So you can have a look at it now. And if you work on the local version, it's a lot faster than it. They haven't cropped the leaves off. That's a bit off, isn't it? But there's your board. You can have a play with it. You can't actually turn the VR in. It doesn't actually work. But certainly on a bigger board, especially if you're trying to fit it within a case, it's quite handy to be able to see. You can see the clearance, and suddenly you think, oh, hang on, I've got a knob just where that capacitor's going, and something like that. So it's quite handy for that. And you can check the connections that we're using, our input and our output. Have we got the right connectors? So that's quite a handy little add-on. But it's just a novelty factor.
Incredible, isn't it?
Can you go back to various stages of what you've been through? Like if all of a sudden you decide, right, I want to go back and
Yeah, absolutely.
start midway somewhere.
So that capacitor there is definitely the wrong one. C1, it's the wrong thing. Let's go back to our schematic. C1 there. Right, we change that, just delete that out. Go back to our components, which is that one there, and let's find a more appropriate capacitor. So those are capacitors. It's what we put in there is a radial 0.2. So these are all surface mount devices. If you've worked surface mount, you recognise 805s and 603s. Those are the dimensions in, I think that's,
Inches, aren't they?
it's an imperial, isn't it? I think.
Yeah.
An 805, isn't that 50th of an inch by an 80th of an inch or something like that? I can't remember what it is, but that's the size I know working. I can do 805s and I can just about do 603s, but 201s are a bit too, 402s are too small for me. Anyway, we want a radial one, but not quite such a big one. Let's go for that. If the one we want isn't just there, we can always go into the library and find a specific one. We can search, if we have a part number of the one you've actually got the capacity, you can search for it and find anything you want in the library. I think pretty much everything's in there. And if you've got something that's really esoteric and it's not in the library, you might see a few references here and there. There is a component designer, so we can design our own components as well. Generally, you're only doing that with chips, so I've drawn one or two ICs up that I couldn't find in the library. Well, they're now in the library because I put them in there, but it's not too difficult to draw up an IC. The tools are very, very similar. You just draw the IC up. You map the pins on the schematic to the pins on the PCB, that sort of thing. Anyway, we'll just go for, I've forgotten what slide we were looking for now. We were going to go for a 0.1 inch pitch, one standard component. So click on there, let's pop him into here. I'm calling you rotating, yeah. So rotate it around, behind on there.
Andrew, you say that the product that we're using here is Chinese.
Yeah.
How extensive is the library? Does it recognise, for example, CPC, Farnell, RS type components?
It recognises it's a LCSC. If you see there, LCSC is they are a component source like Farnell. So pretty much anything that's in the LCSC catalogue will be in this library here.
Mm-hmm.
But there's other stuff that isn't in there as well. I mean, the manufacturers say that this is stuff. So they where it says extended part, LCSC, a part of JLC PCB, there's two divisions to the base. There's the PCB side of things, and then there's the LCSC, which is, say, it's like your Farnells and your Mausers and people like that. So there's loads of stuff that they sell. In fact, they tend to have a pretty good range these days. But they've got a set of parts which are standard parts, which if you get them to build for you, the components price is incredibly competitive on those standard parts. And then they've got most parts, as you see, they're extended parts, which tend to cost more, sort of going market rate. And we'll see, there's a standard one there that just gone past. There's a basic part there, so that's a surface mount. We're still searching through the 317s, so that's a 252 footprint. So not no good for our project, but that would be a dirt cheap part. That when we came to the pricing, I doubt that would cost you many pennies. But, yeah, if you could search on any you want it. So if you look up here on these tabs here, this shows you where we're actually searching through the LCSC component list. I think that's just the stuff that they can assemble for you. So there's different things user contributed there, so 999 plus, so there's zillions of stuff in there. And so if somebody's actually drawn up the part and put it in here, then it'll be available for you. So because the stuff that I've drawn will come up under user contributed. I doubt if I'd have put manufacturer's part number on there, I'd probably just do like a generic version. Let's go back to our drawing. Oops, we've got another regulator. Right, so I've changed the value to put the U on the end. I don't want people thinking that's a pico or anything like that. And pop that one in there. Now that's back in the diagram, exactly the same place. But what we've actually done is remove the old one and put a new one in. So when we go to design, we do update PCB. You could do that, actually create another new one for you, and you'd actually get a second tab come up. We're just going to update the existing one, that one there. Please save your work first, forgot about that. So Control S to save it. Try again, update the PCB. And what it'll do now is it'll tell us we're going to add a new C1 and remove the old C1, and the nets that are affected, it's going to remove those are the nets that were connecting. You know, the nets are the tracks, effectively. That's what was connecting to the C1 removed, and we're basically putting the same thing back in again. So apply that, and I expect, that's the design rule, something like that. Yeah, I thought as much. Our capacitor's now over here because it's a new part. And because we haven't rerouted it all, we've still got our old tracks there. So if we grab our C1 there, up and back up here, rotate it, and clean, because it's a new part, we haven't got our name displayed, so we'll turn that back on as well. Yep. I can't remember where it was, we'll put it roughly in the right place and we'll reroute it. Auto route. Keep the same design rules, you should have remembered all that. Do it this time.
You've got overlap. You've got over.
Ah, the silk screen, yeah, so it's going to look a bit messy, but I mean I can mess around with that and move everything around. Usually when I do mine, I'm a bit finicky about this, I tend to rotate everything so it's all upright in all the same direction. I'd move all that lot over the top here and things like that, but it'll take ages doing that. You can have hours of fun doing things like that, but I won't try and do it here. We should be okay there now. If we go over here to Design Manager, we have these bits here. So this is important, this one here. This is DRC, which is, I think, Design Rule Check, I think that stands for. And this will check if there's any blatant errors. You know, we've got tracks crossing each other, or positives connected to negatives, things like that. You'll see it's at 0 at the moment, which is good. It's always worth pressing that button there just to recalculate it. And we've still got 0 errors. So if there was any errors, any pins not connected, anything connected to the wrong place, it would come up here with a list of them all.
Does it detect short circuits accidentally?
You can actually do that. I was trying earlier on, because I was trying to create an error, just as an example to show, and I couldn't create one. I think the only way you're going to create one is if you take your cap, say, and move the cap over here. Now we've got a short circuit, so you've got a little cross there.
Yeah.
We've now got a short circuit between the positive of that capacitor down to the ground plane underneath it. And if we, in theory, if we rebuild those, yeah, there we go. So we've now got 2 errors, which, if you don't fix those, they'll quite happily manufacture it for you. But they won't work very well. So we need to clear those errors, fix those. I mean, we could mess around with things, but the easy way to do it, either we need to rebuild our copper layer, which will fix one of them, I think, if we do that. That actually fix both of them. So where's our positive connected then? Oh, when I moved it, it must have dragged the track across or something then, because the positive's still connected. It was over here. Notice the ground connection, as you can see there, the castellated, it's quite a nice little feature. You can turn that on and off if you go up here somewhere. So that doesn't have to make it easier soldering. When you've got a full ground plane like this, it's done have suck the heat out of the soldering iron. So castellating your grounds connections is a good idea. Anyway, we've got no errors now, so we're okay to go to the next stage. So the next bit's the exciting bit, get your credit cards out. This is where we order it. So, have we saved it? No, we've got star now, we just need to save it. And if we go up to fabrication, PCB fabrication file, so notice there's Gerber there. If for those of you that aren't doing PCB manufacturing already, a Gerber file is a standard for defining PCBs. So just like PDF files are print standard, Gerber is a standard for how to define. It includes all your cutting, your dimensions, your track layouts. It defines everything. With this, you don't really need to know too much about it. Just recognise the name. If we click on that, again, check the design rules. Would you like to do a design rule check before generating Gerber file? I've never said no to that question, so I don't know what happens if you do. I always say yes. It's just, even though I've just done it once, you just do it again. Right, so there it is. It's come up and it's quoted it for me. And it's your price. And that's not actually an accurate price, because you'll probably find in a minute it gets less. 5 PCBs. So we can play around with a bit with the quote here now. 5 is not enough for you. We'll have 10.
What's the minimum? 5?
5 is the minimum, yeah. So it adds another $1 if you want 10. We can play around with a few of the basics here, but I'm not sure why, because we'll get another chance of this in the next screen. Pcb thickness, 1.6 is pretty much the standard for most PCBs. If you go up to 2 mil, it gets quite expensive, I think. Yeah, $34. So you don't want to spend too much time playing with this, because things get more expensive. The thinner one is back to $2, $4, sorry. What's delivery time? 3 to 7 days as well. That's the manufacturing time. So we'll stick with the standard 1.6 mil. We can play around with the colour, green. Notice that's blue, you notice there's green there, because it doesn't reflect it on there. There's actually more colours than this available, so I don't know why they haven't updated it.
They got a new kind of burgundy colour came out this week
purple
as well.
Do you use GLC PCB, do you? Yeah, they're great, aren't they? Yeah, so things like your surface finish, that's
What's that?
leaded. If you want to go unleaded, you can go there. If you're a bit of a, you like to punish yourself.
So
It
the
costs too much more, but for those health and safety freaks, you can go unleaded if you want. I don't know what that is.
It's ENIG, it's gold plating.
That's gold plated.
So
Yeah, how much that costs?
So the HA, what was it, hassle? The hassle is hot air solder leveling, and they basically put solder over all of the copper so that it doesn't tarnish.
And that looks like it does in the picture there with nice gold plated holes. But I mean, for those of you that ever did this in the past, the reason you never used to make your own get your own PCBs produced in the past was because the cost of a PCB like this, you probably would pay what, 500 quid setup fee for it.
Yeah.
Maybe you only paid £1 each for the PCB or 50p for the PCBs, but there'll be a £500 setup fee for something like this. So $21 for a gold plated PCB is actually still a pretty damn good price. Anyway, we'll stick with leaded because I'm not a masochist. It's so much easier to use. Copper weight, if you want a heavier duty copper, again, you've got 1 ounce or 2 ounce. But this is just a basic quote here. Let's go through to, you can generate the Gerber files from here. If you want to actually download them to your own PCB, you don't have to buy from GLC PCB, even though you've used their tools to design it. You can use this and then go and order them from
PCB Way.
PCB Way, which is another Chinese manufacturer.
Are there any in the UK?
You'll pay about 50 times the price.
You could use it if you can find a UK manufacturer still in business. You could use them, yeah. But they're horrendously expensive. They always have been, always will be. They'll never match the Chinese on price, I don't think. But you could generate your Gerber files there, and then you can download them to your PC and send them off to your favourite manufacturer. But we'll use order the PCB at GLC PCB because it all ties in.
Do they offer you the choice of populating it?
We'll get to that in a moment, yeah. So order date is generated, please click OK and continue. And that'll take us to the ordering page, eventually I hope. There it goes. Right, so it's now, their ordering system is now importing automatically, so you don't have to worry too much about Gerber files because they take care of it all for you. There's one thing to be aware of, if you're making if you work for the MOD or something, you make some top secret new military weapon, just be aware that they've got a copy of your PCB. So all your work is being saved on some server in China. I'm sure the Chinese government will check every single one to see if it's of any interest to them.
So you're handing your copyright over as well?
No, I don't think you are. I've never seen you mention a copyright. I don't know who has copyright. There is a section where you can make your projects public, so you can publish them to other people. I think you can publish them to anybody if you want, or to selected people. And if you remember back on my original page, there was another set of stuff at the bottom, 'cause I've got some stuff I've collaborated with somebody else. In fact, I should be able to find, if I can find the original screen. I'll have to go back out of full screen mode to find it, because I don't know how to do it otherwise. Go back to that tab. Close that off. You go to the project down here, so you see this is actually my nephew, and I've worked on a few projects with him. So we collaborate on this. He has the same projects, and we can both edit them. So it's not just a basic, home construction tool. This is actually quite a fully capable tool. So there is proper collaboration stuff in there. And so you can share your project with selected people, which is what we've done here. We both share with each other. You can select it, share it with anybody, or you can keep them. All of these are my private ones. Nobody else can see any of these. Let's get back to our quote anyway. Let's get our Pcb order if I can see the button. No. Right, so this now allows us, this is the actual ordering page. It allows us to set a few more parameters, the same ones we had before. Well, I'm not quite sure why they had them before. They've just added these aluminium substrate ones, which are, I believe, the same price. Talking of the price, you should probably, notice the price is now gone down. It's in pounds because I'm logged in, I always have it in pounds. It's $1.46, which is actually, if you do the maths, it's $2. So even though it said $4 on the first one, it's actually come down to $2. I'm not quite sure why. You know why it comes down to $2 like that?
It's not your first order, no.
It's certainly not my first order, no.
If you do, they give you a credit on your first order as well,
Yeah.
but I don't know why
Yeah.
you've got a discount.
Yeah, I seem to be getting that all the time now. I mean, for a while I wasn't getting it. It was like $4, but now recently it seems to have gone back down to $2.
I think sometimes it depends on how many. If you were to change the order, how many you want, back to 10 or something like that, sometimes you don't
10.
get the discount again.
Yeah, you only get the discount on the basic $4.
And I think also some of it is because they batch all these up. They're not making your board. They're making about 20 people's boards all at once, and they batch them onto a big panel, and then they run them through, and that's why it can take 3 days to manufacture the PCB. Not.
So at the top here we've got a handy picture just to remind you, make sure you're actually ordering the right one, you haven't picked up the wrong one. And then down here you've got all the detailed stuff, so you can choose aluminium, which I think is the same price at the moment. We're a 2-layer board. You could have gone for more layers, but we don't need them. I think the 2 layers is the same price as the 1 layer, so there's no point going for 1 layer. There's our dimensions, our quantity, different designs. You can put multiple designs on the same order, so we could, because this is quite a small board, the price is the same right up to 4 inches by 4 inches. So we could have added another, some other bits and pieces in on the same board and got them all fitted in together.
It does cost you more money to do it that way sometimes. Sometimes it's actually cheaper just to get them to run them as separate orders.
Yeah. You're playing with it, but I mean, you're talking a difference between $4 and $5. It's not the end of the world if you get it wrong. There's our PCB thickness. We've got more options now. There's our colour. There's our new purple one. That's only just been added recently, and it does reflect it on here now. So we have a nice purple PCB. I haven't got any purple ones yet because they've only just added that. Silk screen colour. Vast choice of colours. It's white. Unless you have a black PCB. Sorry, a white PCB. If you have a white PCB, it can be black. But apart from that, it's always white. You know, I got a yellow one. I'm sure I have. Oh, maybe it's white. I can't remember now. Surface finish again, same as before. What's that? That's the copper weight again. Gold fingers. If you've got edge connectors on the thing, you might want gold. Just those being gold plated, not the whole thing gold plated, just the edge connectors. That's, I think if they do that, they check the board over and then send you an email to confirm it's okay before they go into production. Or to tell you about any errors. So if you've got any errors like that, they'll tell you, and you can actually say, okay, go ahead with it, or no, cancel that. But hopefully you've done all your DRC checks anyway and you haven't got any errors. That seems to be always included. I think that's just continuity testing across all the tracks. Castellated holes, not quite sure what that is. It's something to do with the edge. Do you know what the castellated holes is? No. It's something to do with the edge of the PCB, castellating the edges of the PCB somewhere.
Was it the mouse spikes? If you were to, is it for that? If you want to make a PCB that you want to be able to easily break, then you can put little mouse bites in there, but they normally charge you a lot more for that.
Yeah.
So if you were to pick yes, how does the price change on that?
It did put
Does
the
it
price
rock
up
it
when
up?
I picked it before.
Let's see. No. Don't know then.
Castellated price. No, it's the same actually, same price. Last time I tried it, it did change it. So, Oh, well, yeah, I remember what happened because I didn't get this. It says you have to tighten the edges. Because I didn't know what it is, I didn't know how many edges it were, so I just turned it off. That's why I didn't change it. Remove the order number. They will put an order number on your PCB on the silk screen automatically. If you want to get rid of that, it bumps the price up by $1 or $2. If you don't have it, I presume it means they've got more handling costs because they've got no way of identifying the PCB without that order number on it. You can specify where you want it on your. If you don't specify it, they'll just randomly put it somewhere. They invariably put it in the worst place you can possibly imagine. If you want, you can specify a location. If you click that, you've then got on your silk screen, I think you've put the words JLC PCB twice on there, and where those two are put on there, it replaces that with order number. I don't think that costs an extra.
What they won't do is they won't ruin your silk screen with their little
To be fair,
code. So I never bother. I just let it run through. And
if you look at all my examples here, I don't think I've ever bothered removing it, so you'll see them on there somewhere. I'll look around until you find them where I send the examples around.
the reason you might do it is some people produce front panels and things like that.
Yeah.
The last thing you want is their order number on your front of your panel.
Right, assembly. I've never used this, I'm not going to go into it tonight, but it's there. If you turn that on, you can then get them to assemble stuff. It's at SMT, so I presume they only do surface mount. They're probably not going to do through hole.
I think they now do through hole as well. Maybe you can't order it through that service, but it's quite new. That service.
It's really half the fun of building a project is building the project. So I've never used their assembly service, but I've read reports from other people, and apparently it is first class. They do a very good job. And if you're doing surface mount stuff and you don't fancy handling it yourself, particularly if you're going to order something with a nice tiny little surface mount integrated circuit on it, it may well be worth just getting them. I think if you use this service, you can choose which parts you want them to assemble for you. So get them to put the really difficult stuff on and do the rest yourself. So click that on there, and I'm sure there's all sorts of things.
Will they supply components?
Oh yeah, absolutely. They will supply the components as well if you want. Obviously, they're
Pay
assembly,
for
they have to do
it.
that.
It's not free.
As part of this.
Part of this service, yeah. If we upload the bill of materials, we can go in. We'll have to link, what we actually want to order, the specific part numbers for each part. But you can order a complete every single bit that you want as well, so it all comes together in one package.
Before you do leave that screen, can I see the shipping cost?
I'm just about to get to that. You probably need those brighter-eyed amongst you. Right, so that's a problem. I mean, I'm paying $2 for my PCB.
That's DHL.
And I'm not going to pay £18.24 shipping. I have on occasions when I really need it quickly, so 2 to 4 business days. If you really need it quickly, it's your decision. Personally, I'll never use that. That's the one I use. Special airline. So special airline, £1.27.
That's crazy.
So that's going to. I presume that's going to.
That's a one-engine jet.
That's an unfair price, really. If you're buying bigger boards or more than 5, you'll pay more. So as soon as you start changing quantities or the size, that's a very small board. As soon as it goes up, the price of your shipping will go up. So you won't get a 10 by 10 board, for example, which is their kind of the maximum that they'll do at a reasonable price. With shipping at 127, it goes up.
The
quite
key
quickly.
size is 4 inches by 4 inches. As soon as you get above 4 inches by 4 inches, everything starts to get more expensive. If you stay below that, then your shipping will stay low and your board costs will stay low. So we've now got a total price of £1.46 plus £1.27. That's our bottom line price we're going to pay. So £2. What is that? £2.70 odd.
That's for fine.
For 5 boards, yeah. All right, it's going to take them 3 to 5 days to build it. I think they said, and 8 to 14 days. Now in practice, I usually find it arrives within about 12 days. So that must be coming by plane because there's no way a boat gets you that quick. So
You're stuck in Felixstowe at the moment.
if they got 3 days to build it and I'm getting it in 12 days, I mean occasionally it doesn't come in 12. As you say, worst case, I think they said 5 days to build it and 14. So you're looking at 19 days worst case. But I say generally, I think my experience, they are usually about 12 days.
What's the next?
How fast do you find it?
I always do shipping, and it's about 12. The cheapest, and it's always about 12 days.
What's the next best option after that?
£7 or something, is it?
I have done. I did do the DHL Express once for something I really wanted. I did one and did it slow shipping, and I screwed it up. And so pissed off with myself, I thought, so I'll pay the money and I'll have it quick. And it wasn't actually that much quicker. It still took them the 3 to 5 days to build it, and then DHL took another week to send it to me. So it's about a day or two quicker for 27 quid. So,
And these do change occasionally in terms of the options that you have for selecting. So during this whole COVID period, it went bananas, and you really couldn't get anything for price. But it looks like it's
so
normalising.
FedEx, it's a week. But yeah, if you look at it, we're best case, it's only a day quicker than that one for a lot more money. So unless you're desperate, go for special airline or whichever is the cheapest one. But there we go. So if I save the card and give them my credit card number, those will be here. I'd be surprised if it's not here within 2 weeks. I'm not going to do that, largely because I've already got some here.
Oh, the other thing is when they ship them in batch into the UK, so they don't actually send them directly to you for that money. They'll send them into the UK. They get picked up by Yodel, and then Yodel will do the final thing. What it means is you get really good tracking all the way from China all the way to your door. So if you take the time to actually track it, you'll know the day that you're going to get it.
Web browser. Oh, maybe web browser, not the web browser, there it is. When we get to the other screen. Maybe you know how to get the other screen without minimising it all?
Alt tab?
No, that's what it's on the browser. Another tab on the browser.
Shift tab, is it?
Shift tab on the browser it is. No,
No.
I'll just minimise it back again. Hold on a second. You can see the button, that's the trouble. There you go. That's why I had to get to that one.
It sounds like, Andrew, the hardest bit of the whole thing is picking the components, picking the right type of component.
That's probably one of the most critical things. What I tend to do is, so I've already prototyped it. So, there's a prototype lying around here somewhere, so I've got the components already. So, I know what I want, and because I'm only building one-offs, I've already bought the components. When I tested my design out, I had to have everything to do that. So I know exactly what size they are. So when I get to this stage, I'll look at that capacitor, and I know that's the wrong size capacitor, and I'll go back and choose another one. And if you can't find it in there, it's easy enough. You go into the library, and as you say, we might use the 317. You just click on any of these, you can see what the footprint looks like. And sometimes, certainly with surface mount stuff, I don't know about you, I'm not really familiar. I know the SOT 223, I know what that looks like. But what's a SOT 89? I've got no idea what a SOT 89 looks like. So you click on it and you get a footprint there. There's no dimensions there, but you look at it and you think, oh, that's about right. And then, so you go with it, and then when you get to your final PCB drawing, you can work out, is that the right part or not? It's not very difficult to go back and change things.
The other thing you can do is print it 1-to-1 scale, and then you can apply your components and make sure they all fit ahead before you spend your £4 or whatever.
Well, that's exactly how I used to do it before I started using the Chinese to produce them. When I was etching my own, I get to this point here now. If I print that now, there's an etching method called toner transfer, where you use a laser printer. You print the PCB onto a piece of very shiny paper, and then you transfer the toner off the paper onto the PCB. And you can then etch against that, and that's how that one that's floating around, the silver coloured board, was made. I printed it from here. I would have printed it on my laser printer and etched it from that, and that works fine. If you're in a real hurry and you can't even wait for DHL to deliver it in a couple of days, you can etch your own. I would certainly suggest before you try it on something critical, you have a few practices. It probably took me a couple of months to perfect it to the point where I could actually reliably produce working. I went through all sorts of different processes. Did you go through the etching process? Or?
Yeah, and then there's the tinning process that you can apply your silver one with the
that's a copper board tin with a cold tinning.
Double-sided is a pain because you've got to line your drill holes up. Drilling very tiny holes without breaking the drill bit, it's not pleasant.
There's no through-hole plating on this. If you put wires in, you've got to pin the wires. So there's loads of reasons why etching it's not really.
And the chemicals aren't nice either.
No,
And
they're
believe me,
horrible.
if you spill them somewhere where
Do they
you
stain?
shouldn't spill them,
Yeah.
chloride.
Well, I use a kit you get which comes with a plastic bag with clip-on tops and bottoms, and you open it up, chuck it in there. So it's horrible. It's so much easier to do it this way.
I spent half my life in the dark room with chemicals, so it's.
So
I miss the smell of chemicals.
something else that James mentioned just now, actually, that you could do with this, it's front panels. So there's always a problem when you're building your own project. How do you make your front panel? Especially if you've got square holes in the front panel. It's always a problem to make square holes in front panels. But this, at $2 for 5 boards, doesn't have to be a PCB. You can actually use this to do anything you want. You don't need to make PCBs out of it. So you can make PCBs that look like that. That's a PCB with a front panel.
Brilliant.
And if you snap that off, it fits into, I haven't actually got the case that goes in, but there's another project. That's what they call a clamshell case. It comes apart like that. And inside there you'll see, I don't want to show you too much because this is going to go in the construction project contest in a few weeks' time, but, so no peeking. But there's a circuit board in there with a front and a back panel with all the holes drilled, all the writing written on it, everything's in exactly the right place, and that started out life like that. So that's the PCB. So I'll pass that around, and you can have a look at that as well if you want. Yeah, Tony, you can pass that around.
And that's what some people are using the aluminium
Make the aluminium
PCBs
one,
for
yeah.
as well, so you get a proper.
I tend to
aluminium.
join them on. I'm not sure that it's cheaper to do it like that because it makes the PCB bigger and it ends up being bigger than the minimum price. So I think that order cost me around $20, something like that, for the size of that.
When you look at it, it's worth it, isn't it?
So, sorry?
When you look at it, it is worth it.
Oh, absolutely. If you look carefully on there, you'll find the little ID number they put on there somewhere, I'm sure. Luckily, they didn't put it on the front panel.
So where do you put your dynamo labels
So there's another sample boards passing around. So hopefully, if I can find it, that's what's that? That one there. I'll have a look at. That's me. What's that one called? I wrote it down actually, so I knew I'd forget it. What's it called on the front? It's called a radio switch. Radio switch somewhere on here, so there should be a radio switch there. Whilst I'm in here, just something else I'll quickly show you. On a project, so a project like that radio switch, I've actually gone through a number of iterations of that. And again, this does actually have version control in here. So even though it's a free design project, you thought it was a bit basic, but there is version control in there. So if I pull up that, there's version 1, which is a bit out of focus, I don't read it. That was my initial production version, which I got wrong, and I then made a version 2 just there. So if I switch to version 1, actually I'm already on version 1. If we look at the PCB from that, which I think is that one. There, you can see it a lot, it's a bit dim, but there is the front panel. So you'll see I've got silk screen on both sides, top written there, so I'm working out, if you look on the inside of it, you should see that top written there. But that's on the underside of the PCB, because that's the outside of the front panel. And you can see the drill holes there for the 3.5mm sockets there, so they're lined up with those, so those line up with the 3.5mm sockets. That's the microphone connector. This project is a switch. It fits onto my IC 9700 and my IC 7300, so I can have both of them connected to this. And now we can have one microphone, one headphone. I think it's actually got Keir sockets on it, even though I can't do CW. It's got, if you can read back to front, it's got the headphone socket, key, also key. I can't remember what that's for. That's the foot key, so we've got a foot switch for it as well. So it does all of that. It's all sat in here. So there's a whole load of these are electronic switches So they're like electronic relays, but integrated circuits mount jobbies, which switch all the different lines. So and there's the back panel there, again all lined up with the relevant
So you do
sockets.
those cutouts,
Those are holes, yes.
I know the side cutouts there.
These are slots, yeah. I just marked slots into it, routing slots, so they're all routed out. The little corner there fits into that case, which is going around there, this case here. So, yeah, have a look at that, you'll see it in more details. So that's the sort of thing you can do, when you get a bit more practice in. And that one there, I think that cost me about $20 that board, because it's quite a big board. So of course, once I'd done version 1, I had 5 of these front panel and back panels. So if I change to version 2, you'll see I just ripped all that off the diagram, so it's so there's no point in producing, paying the money to produce those a second time round. So not version 2, version 1.1. That one. I've got to close the current one first. Use the tab.
I want to ask a question. Because it's a radio.
Version 1.1, so a few mods on this. Look at the main PCB on that one. Load it, yeah, it is. And you see the front and back panels are now gone because there was no point in paying for those again, as I had 4 spare sets already. So all I did was just went through and deleted all those bits off of it, made the revisions to the board, submitted it, and paid another 20 odd quid for DHL to deliver it, and got it about 2 days quicker. So very versatile product. It's got lots of useful tools. It's got collaboration tools. It's got version control. So it's not just a basic entry-level product. Do you actually use this now? It's yours, do you?
No,
No.
no, I still use Fusion, yeah.
Fusion, yeah. It's what you know, though, isn't it?
Well, Fusion also allows you to build all the enclosure and model everything. So all the
is that Fusion 360?
yeah.
Yeah. So that's got all the 3D.
That's got all the fabrication stuff, so you can do sheet bending and all that kind of stuff with it.
So
Andrew, if you, obviously that's a DC regulator.
Yeah.
If you were doing something of an RF type orientation, it was fussy on track there, so you want to be careful. How easy to do like a half and half, a partial or route, then to go back and tweak and change track spacing on it?
No problem at all. I mean, we can. We did this one here, which is to say, I would never have done it like that personally. I can just pick it up and move it around now. It's totally editable. The auto router just gives you a suggested starting point. Completely editable. I can move anything I want. That track there is a bit too close to that, so I want to move it down. I just grab it and move it down a bit like that. I can do what I want. One thing I don't think this has that I've never found is impedance matched tracks. If you want to make a 50 ohm track, I think the way I do it, I go and Google it and work out the dimensions. Because everything is completely, you can do it all drag and drop, but you can also go into the into the side here. So if we look at there, the width there, so I've got a width of 1, but if I wanted that to be 0.95 instead, I can just type it in 0.95 and it'll change width. You probably couldn't see that, was such a small difference. Let's type it in the right place. I did, yeah. So the width now is 0.95 millimeters. So that track, I could, if I know the dimensions I want, I can impedance match it. Okay. So if I wanted a 50 ohm trace, I would lay another couple of tracks either side of it and calculate all the dimensions, and instead of just auto it, I'll just type it all in by hand up here.
And you can also set all your nets up ahead of time. So if you know that these particular traces here need to carry this particular current, and you know all that in the schematic level, you can set all the nets up.
Yeah.
And then when the auto comes to run the auto routing, it's the same in all of them, because it knows the net classes that each of the traces need to be. The auto router was okay. This one needs to be 3 mil. This one can be half a mil or whatever.
That's really good.
You can take that one there, which that one's not carrying a lot of current, so 1 mil a bit over the top. We can take that down. Let's take that down to 0.2 mils. And in real time, there it is. So this one here, if this was one of our main current carrying one, in fact maybe 1 mil is not enough, so let's put that up to make it 2 mil, and maybe a nice big fat track. And once we do that, we'll probably find we've got look, we've got crosses there. We've got an error there because the clearance is too small there. Remember, I set the minimum clearance to be 0.5 mil, didn't I, or something?
Yeah.
And that's now too close there, so we've now got a DRC error, which is flagged up here with these crosses. So if we go into our design manager and refresh the errors, yeah, we've got quite a lot of errors now, clearance errors mostly because I've just been messing around with track sizes. But, yeah, everything and anything is editable, so you can just move it all around, move your bits and pieces around like that, all that sort of thing. Yeah, I mean, I haven't put a lot of effort into this. I've just done it in real time. In fact, I should be able to pull up the one that I actually produced. I think I find my projects list. That was I think that's called SDR demo, if I remember rightly. Yeah, that's in there. So this is the one that's circulating, which on this one I added in. It's interesting, I didn't have the fuse in there. I thought I had the fuse in there, but obviously I didn't. Let's have a look at the schematic. Maybe this is a version 1 because the one that's circulating has got a fuse on it. Is there another version? No, there's only one version. All right, I must have lost that one somewhere along the way. This talk, I was originally going to do this talk before the pandemic, so I'm trying to remember back to 2 years ago when I originally drew this. Anyway, somehow or other the final version's got a fuse on it, but the drawing doesn't seem to have. Right. So all this is very timely because in about a month's time we've got the construction contest coming up.
It's just said to me I don't have a chance.
Well, you do. You've got.
Everyone's got a chance.
Even if you go for the slow boat delivery, you've got at least 2 weeks to design and build it in.
I've just seen what you're going to put in though.
But you might be in a different category.
Yeah, don't get into the same category. We usually have as many categories as we have entrants, don't we?
We can do.
It's RF circuit design for the beginning.
First time. There are so many different categories we can
I think what
do.
we should do, we perhaps should consider a companion one for one of the software, for example.
There is a software category as well, isn't there?
Devices, yeah. Because there are some good ones now, even for people, anyone can use it. I use a couple of them. You don't have to think about getting a soldering out to test it out. You just, oh, that's right, I can make it. And then even produce if you want.
I do a lot of simulation before I
Yeah.
start drawing things out for the simple reason
I
is
do these.
my knowledge isn't good enough unless I prove that it's going to work.
It's good
Then
practice anyway. Why not do it? You know, just
So that one there is a well, no, I say Arduino base. It's actually an ESP8266 base. See the Node MCU board on the right hand side. That's one of these little. It's like an Arduino but on steroids. So same sort of thing. So that's this is actually my 10 meg reference oscillator that I use in the shack. So it's GPS derived. So that there is as it says, a Node MCU. It's an ESP8266 chip. Oops, press the wrong button. And over here, that's a GPS module. So that's one of these U-Blocks GPS modules. About £7 or £8 for a GPS module. Gives you a serial output. That serial output's fed into the microcontroller here. It also it's got a programmable pulsed output on it. So the microcontroller initially programs this into a mode where it generates. I think it generates how fast is it? It's a while since I built this now, so I'm trying to remember. I remember the problem was that the GPS oscillator, the native GPS signal, isn't divisible down to give you a 10 megahertz reference because of the way it works. If you tell it to give you a 10 meg output, you get a lot of jitter on the output because I think do you remember what the basic reference volt frequency is?
no, I remember we spoke about the jitter a long time ago, but I don't.
I can't remember what the number is, but it's something like, say, 50
It's
megahertz
49
output.
point, it's 49 point something.
Yeah, and if you divide it down to give it to 10 megs, it will give you exactly 10 million pulses per second, but they won't all be 1/10 millionth of a pulse per second long. What it'll do is it'll shift them to get them to fit into the space. So to get a jitter-free 10 meg reference oscillator out of it, you have to divide it down to, I've divided, well, you don't have to, the way I've done it, I've divided I programmed it to give me a 1 meg output. So it's divided down to 1 meg, which gives you a jitter-free 1 meg, because that's an exact divisor of the basic frequency. That 1 meg output then is fed out here into there's a phase lock loop on here somewhere, one of these chips here. You see which one it is?
Left-hand side, go look.
That's the
Oh,
phase
that's
lock.
LED, sorry, that's LED.
Yeah, 7046, that's a phase lock loop there, which I'm using as a frequency multiplier. So I would imagine that's the 1 meg signal coming in down there, which goes into the phase lock loop, gets multiplied by 10, and it gives me a 10 meg output, which comes out just there. Well, it's in the middle of that, somewhere in the middle there. But sorry, it gets to just there, there must be a track somewhere. And that's the 10 meg output, which is fed out to the front panel, which I think the board's going around somewhere, but it's basically that board there. So that's the front panel. There's a hole there, which I think has got the 10 meg, an SMA connection on it. And I get 10 meg out of there, pretty much jitter free. This project, because it's sitting there doing all this, it's also just happening to have an incredibly accurate real-time clock coming out of the GPS as well. So that real-time clock output is also fed into the microcontroller here. And this microcontroller hasn't got a lot to do apart from programming the GPS. So I added a bit of code in there, and that now contains a full-blown NTP server, and it gives me whatever the tier 1 reference time for all of my computers in the house. Another one of my favourite pastimes also is building clocks. I love building clocks, and I built all sorts of, well, you've seen a few of them, haven't you, Roy, of digital clocks which are all synchronised to that GPS that's inside that unit, so because it's NTP onto the network. And I build a clock with a microprocessor in it that sits there and it talks NTP to this unit, which then synchronises its clock. So shortly after it powers up, a couple of seconds later, it gets an absolutely spot-on clock. So all my clocks in my house are all synchronised to within a couple of microseconds of each other, including all my computers, which are all tier 1, Stratum 1, I think, Stratum 1 GPS synchronised. So that's something you could do quite easily. I don't think I've ever entered that one in the construction contest because it's not really radio, is it?
You entered like version 1 of it.
Oh, I did enter
Yeah,
it.
yeah.
No, we're up to version 3 now. I think version 1 was hand built, wasn't it?
Yeah.
It was all on stripboard or something, yeah. Which didn't last that long, which is why we decided PCB was a better bet. So yeah, if I go back through the version, that one's probably in here as well. But yeah, this is version 3 now. Actually, last year that's time I did that one. Copyright 2020. So not that long ago. So GPS NTP server. So that's the sort of thing you could do quite easily. And I don't know what that one cost, but looking at the size of it, I doubt it was more than about $8.
How long did that take you, do you reckon?
Well, if we look at version 1, it was probably 2018 or something. No. It's with that actual version. I mean, the drawing the PCB up, because I'd already done 2 versions previously. It was only a few twiddles off the original design, so I don't suppose it took me 1 evening or 2 to do it. The circuit diagram's probably not that.
And it's also relaxing. You can do it watching the TV. I've done it on the beach, waiting for a plane. It's just you can shut your brain down and just.
Landing on the beach.
It must have been an empty. It must have been an empty beach.
It's just.
It was after the plane landed.
It's just relaxing.
Nothing else nice to look at.
Yeah, so this project's drawn on 2 separate sheets. So that's the phase lock loop stuff there, which you zoom in a bit. That's the phase lock loop there. This is divide by N chip. It's a standard 7-pole part, so probably recognise the 7-pole that's 90. It's set up to divide by 10. The way a phase lock loop works is you use a divider to generate the multiplier. So it's quite complicated to explain. I won't go into the details now, but largely I've forgotten most of it. That basically locks that signal to that signal and gives you a nice 10 meg output on it.
So that's all the phase lock loop stuff here. That's the matching to give me a 50 ohm output because I want to do a 50 ohm on it. So it's buffered through a 7414, which is just a inverter buffer, through a 50 ohm output impedance and to the 10 meg output there. And then that's the microcontroller circuitry, which not much to that. It's just there's the microcontroller itself. A few LEDs, I think, isn't that? Oh no, that's connectors.
Did the auto router cope with all that?
No, back
No.
here, this was before the auto router used to work. I manually routed all this. There's a little buzzer on there because every time it receives an NTP request, it goes beep. Sits in the corner of my office, doesn't it? While you're going beep every now and then.
Yeah.
It's pretty unintrusive, but that's a straightforward thing. So that's a handy thing to do. That's nothing to do with the circuit. I just drew that on there because when I'm building it, that's the pinout for that device. That's that transistor there. I find it quite handy just as a way of documenting it because you can always Google them, look up pinouts, but I seem to spend half my life looking up pinouts for things. So I got to the point where I just draw them on the circuit diagram there. That's probably all decoupling caps there, I would imagine, and an LED at the bottom. I don't know what that is. An 1825. What's an 1825? I can't remember. That must be. That's probably a voltage regulator. Actually, looking at that. Yeah, that will be a voltage regulator. It's probably producing the 3.3. Yeah, they are 3.3. Because the microcontroller runs on 3.3 volts. What's not shown on any of this circuit diagram is the power supply. So in the actual product, I built a power supply here as well, which is off-board. So yeah, that's a slightly more complicated product. This is just straight out of the library. Entire microcontroller like that is, those sorts of things are in the library, and Arduino's in there. Yeah, the 3 to 8P chips if you use the chip direct.
There's a GPS in there as well.
The GPS, can't remember. I don't think it was. I think I drew the GPS up myself, which is why it's a bit rudimentary. Where's the tab gone? Is that one there? No, that's the. It should be. Oh, I've lost the. Let's find it from here. It was on PL, isn't it? That one there. No, I think not. Yeah, on here all I've done is drawn the socket for it somewhere. It's just socketed. Yeah, so I didn't do that. And the PCB is. Oops. So a few tabs when I get to it. I think I just drew a square on that, so I didn't create a problem. Yeah, I just put a 4-pin socket and drew a square where it fits. I think if I remember rightly, on version 2, I did this upside down, so I drew them alongside the board. So if I put it on the bottom of the board, it would have worked. But I had the connector back to front, so that was the difference between 2 and 3. I think, so I had to switch the GPS around. But, yeah, so what I choose to do, I didn't create a proper component, just drew that up by hand. But easy enough to do. So this is all manually routed rather than auto routed. Back when I did this, the auto router didn't work very well. They seem to have beefed that up in the last, well, during the COVID period, it's massively improved. It mostly works now, although it doesn't produce pretty results. I think certainly for a simple one like this, I don't think I would use the, well, I didn't auto route. Is that the one? That's the one we just did, isn't it?
Yeah.
Yeah. So yeah, it's not too bad, but I'll bet if you go through those traces, there'll be some earth traces on the top which don't need to be there. Yeah, that's ground there, isn't it? Yeah, ground. So that trace right way through there isn't needed. Yeah, the ground plane does that. So lots of things like that. Yeah, I would get to that point. To be fair, I would probably now spend another hour or two prettying that up a bit, making it do it the way I wanted it. Right. Any questions? Or any more questions?
Incredible.
Well,
I look forward to seeing all of your projects then on the construction contest.
yeah,
Thanks a lot.